Hi students, in this video we're going to cover increasing and decreasing intervals. Get that out of here. So our objectives are to use interval notation to express when a function is increasing, use interval notation to express when a function is decreasing, and determine relative extrema from a graph. All right, so a function is increasing if when the x values get larger, the y values also get larger. When we're looking at a graph, what that means is that if we trace the graph from left to right, when we continue to go right, the graph continues to go up. So let's get a different color. Let's go with orange. So if we trace this graph, we'll see that from, we'll say negative infinity to, can I change the thickness of this? Uh, yeah, so when we, let's use a highlighter instead. So if we trace the graph from left to right, as the graph, as we go right, the graph goes up, and it stops at the x value of -3. So one interval for which we're increasing, we could say the function is increasing, and we'll say on the interval from, so far we know from negative infinity to -3, open bracket. And then when we continue tracing the graph, we go down from the first green point to the second one, but then we continue to go up again from x equals 1 to x equals 4. So our other interval where the function is increasing is going to be from 1 to 4. And we always have parentheses on these intervals, even if x can equal that value. So we're going to put increasing right here. So we'll put increasing and also increasing on that interval. So that's it. So we read the graph from left to right, and if when we go right, the graph goes up, the function is increasing. So decreasing works the same way, except when the x values get larger, the y values get smaller. So if a graph is, this should say decreasing, my apologies, I just copied and pasted it and didn't catch everything. So a function is decreasing if when the graph is moving to the right, the graph of the function goes down. So when we trace our function, we're going to be going up. So that's going to be increasing. But then at x equals -3, let's use pink instead. So when x is -3, we're going to start going down until we get to x equals +1. So the only interval where we're decreasing is, so decreasing is going to be from -3 to +1. And this is always for x values, never y values. So decreasing means that from x equals -3 to x equals 1, the graph is going down. And if we continue to trace the graph, we'll notice that the graph is only decreasing on an interval and increasing, and then we'll talk about constant on the next slide. So a function is said to be constant if when the x values get larger, the y values remain the same. So if we trace our graph from left to right, we'll see that the graph is increasing for a while until we get to 1, is decreasing from 1 to 3, increasing from 3 to 5, decreasing from 5 to 9. But then at x equals 9 to 12, the graph, the x values get larger. They increase from 9 to 12, but the y values stay -2. So this interval where the graph is a horizontal line is where we would say the graph is constant. And all that means is that when you're looking at the graph from left to right, if the x values get larger, but the y values stay the same, that means the function is constant. So again, x increases from 9 to 12, but the y values are consistently -2 or constantly -2. So that's what it means to be constant. So we also have a thing called relative extrema. And relative extrema are where the graph switches from either increasing to decreasing or decreasing to increasing. Those places are called relative extrema. If a function changes from increasing to decreasing, that means that the point is going to be a relative maximum. And if the function changes from decreasing to increasing, that's going to be a relative minimum. We can see this on the graph. So let's use a bright color. So at x equals -1, our function changes. Oh, go back a slide. So at x equals -1, our function changes from, we're going to do decreasing in red and increasing in green. So the function is, we can use a different color though. So the function is decreasing at net, we'll put decreasing, we'll highlight that in red and increasing in green, just so we're clear. So then the function is increasing from -1 to +1, and then is decreasing from 1 to infinity. So the places where we switch from increasing to decreasing, that's going to be a relative maximum. So at x equals 1, so we're going to actually write the point. The coordinate is 1, 2. That is called a relative maximum. And then at -1, -2, so -1, -2, that is called a relative minimum. And all that means is the graph changes from decreasing to increasing for a relative minimum, from increasing to decreasing for a relative maximum. All right, so this is a quick check for you. Pause the video and see if you can tell me where the function is increasing, decreasing, where it is constant, and where it has relative extrema. Assume the graph stops, the endpoints are -5 and +5, so we won't have any infinities for this one. All right, so you should have determined that the function is increasing. That's going to be where the graph is going up. We said we would use green to highlight increasing. So from -4 to, we're going to say that's -3, the graph is increasing. And also from -1 to +2, the function is also increasing. So we have two different intervals. So we're going to have from -4 to -3 union, we have -1 to 2. So decreasing, we said we use red. So the function is decreasing from -5 to -4, and also decreasing from -3 to -1, and also decreasing from +2 to +3. So we have -5 to -4 union -3 to -1 union 2 to 3. Oh, that burns the eyes. Okay. And so then constant is going to be where the graph is a horizontal line, and that's obviously from, we'll use this blue. So that's going to be from 3 to 5. So we'll put in 3 to 5. So 3 to 5 in interval notation. And where we have relative extrema. So where we switch from decreasing to increasing, we have minimums. So let's put our minimum values first. So our minimums are, so we have a minimum at -4, +1. So -4, +1. We have another minimum at -1, -2, and that is it. We have a couple of maximums at -3, +4, and we have another maximum at 2, 2. So x equals 2, y equals 2. All right, so again, minimum is where the graph switches from decreasing to increasing. So that's going to be from red to green. And we're going to have a maximum where the graph switches from increasing to decreasing, or from green to red. And so then a quick review of stuff that we should already know. The x-intercept is going to be where a graph crosses or touches the x-axis, and a y-intercept is going to be where the graph crosses or touches the y-axis. For the x-intercept, y must be 0. For the y-intercept, x must be 0. So we can quickly go through and list our x-intercepts. We'll do those in, we'll use the x-intercepts in black. So we have an x-intercept here. Make sure you express these as coordinates. So it's going to be -2, 0. We have another x-intercept of +8, 0. And we'll say that's 12.5. So then we have one more of, I can write a 12. So we have one more of 12.5 and 0. Y-intercepts are going to be where the graph crosses or touches the y-axis. We only have one. You only have one y-intercept for any function. In this case, that's going to be 0, 2. So don't write in blue on blue. So we'll do that one in black as well. So we have 0, 2 as our y-intercept. All right, so that's going to conclude our video on increasing and decreasing intervals. Quick review. A function is increasing if when we go from left to right, the graph is going up. Function is decreasing if when we go from left to right, the function is going down.